Hello my friends! You know I usually don't do tool reviews, but today I've got something worth making an exception for. The Metal Fab by xTool. A 4-in-1 laser powerhouse that acts as a cutter, cleaner, welder and engraver, and combined with their CNC platform achieves precise cuts in record speed. And honestly, even if you're not interested in getting one, you might still want to see how this thing will change the way I can approach more complex builds in the future. You've probably heard of xTool before. They had a leading spot in the laser cutting and engraving industry basically since day one, and now they're making laser welding with industrial quality accessible to small businesses as well. So I partnered with them to make a 4-part series with each video tackling increasingly complex builds, but today we're starting off with a first impressions review video. So without further ado, let's have a look at it. The Metal Fab might help you grow your business, but it certainly doesn't make your workshop any bigger. And where do I put this? Oh boy, I've got it delivered. Very big. Thankfully, there are some instructions on here. In the perfect world, getting the CNC table out of the box is a breeze, as it's designed to fold apart and then be its own loading ramp. However, my workshop is too small for the ramp, but it could be easily lifted off the pallet with 2 people. Perfect. Now we take this wrench and lift it up. Finally got everything set up. Pretty late, but I want to try it out. So let's see how it'll do. Stainless steel. Never done that before. First try stainless welding. First try using this machine. Okay, let's go. You can already tell safety works because it did attach the loop. I got a little bit spooked. Started off all right. You can see I was a little bit too fast right here. And now this was very burned out. But you can see there's also a lot of oxidation right there, which I think is due to argon flow being too low. So in the manual it recommended 15 to 30 liters per minute, and I was now doing it at 15. So let's do another one and try it with more argon. So I tried around a little bit with some different kind of welds, and then this one was one of the last ones I did after about 10 minutes of playing with it, and I feel like it looks pretty alright, but let's have a look how strong it actually is. So yeah, I feel like the welds are pretty solid. I don't really have any experience with stainless steel, so let's move on to carbon steel, which I'm a lot more familiar with. Crazy. You know, this bending this feels like it's one solid piece. And I for a fact know that with TIG welding I would have broken this thing off already. At least with my TIG welding. Okay, let's do a little comparison. So these were my first welds I ever did with TIG welding, and I chose this project because the shitty weld job fits the look. And then, just for comparison, this was my latest welding job on the whipsaw. Hard to say how much practice, but I've been TIG welding for 2 years. I TIG welded roughly 40 liters of argon, to put it in perspective. Let's see how I will do with the laser welder. Something that might be interesting, you can see how much heat builds up while TIG welding, which in my cases is very important because I'm often working with hardened steel, and if it's heated up like this, it's basically soft again. So heat buildup, heat soaking into the material is something very important to me. Roughly 2.5 centimeters here, 2.5 centimeters here. Okay, you can see I kind of goofed on the first one. Drifted off a little bit to the side. So you can see there's definitely a learning curve to it. It doesn't mean every weld is perfect, but you can tell by the second one, once I dialed in the movement a little bit more and changed the angle of the material, the weld looks pretty great in my opinion. The cool thing about this, I could basically harden the blade and then weld it afterwards and be totally fine with how hard the edge will be. Editing Sven here. I've been watching some reviews, and maybe just to clarify my point right here, I don't think that laser welding is necessarily better than TIG or MIG or stick welding, but for a business like mine, where I sometimes rely on welding, but I'm not a dedicated welder, I don't get the repetitions in to have that muscle memory and experience to produce good and strong weld joints consistently. It's very nice to have a machine that's easy enough to just pick it up once in a while and then still have a result that's still strong enough to use on functional parts. So just to clarify that. So let's move on to laser cleaning. I wasn't really getting consistent results with this. The reason is you can see the safety loop clamped on there, which if there isn't a connection to the welding head, it won't allow you to fire the laser. And now you can imagine with something that's rusted, there isn't any electrical connection between the welding head and the loop because there's rust between it. It has been very inconsistent. There were some times where it was doing its job nicely, but then also it wasn't doing its job at all. Once the metal had one pass, you can see it cleans easily, but what's the point in rust removal if you have to remove the rust first? And now in case of this heavily rusted hammerhead, I couldn't get any connection, so the laser wouldn't fire. If you were to do something that you are clearly prohibited from, attaching the safety loop to the welding head to close the bridge, it works nicely at removing rust. It leaves a very clean finish. xTool states that it doesn't harm the metal underneath. I wouldn't really attest for that because you can clearly see where the laser hit the material and it leaves faint lines, so I think just the tiniest little bit of material gets removed, but honestly probably not more than if you were to go at it with a steel wire brush or something like that. And then also you can tell on this piece of stainless steel that the prongs itself leave a mark because they scrape on top of the metal. Probably the way to use this is either the attachment they sell online, which I didn't get to test, where you don't have the safety loop anymore, but you have to get in contact with the material via this wheel that's on a lever, or using it on the CNC platform so everything's enclosed and you don't need that safety loop. Rust removal works very fast. This is real time, by the way. It leaves the metal very clean, a little bit rough, probably perfect for painting afterwards. But I have to say, with the safety features intended, not really that usable, unless you want to be a naughty boy and, ignore the safety precautions. Laser cutting is somewhat similar to cleaning in regards that the safety loop seems to be the only failure point. Because of the high air pressure, it's easy to accidentally lift the nozzle from your workpiece. And since the cuts are so thin, it's almost impossible to get it back into the same line you've cut before, which can make finishing a cut a bit awkward. Once again, doing what you're not supposed to shows that the machine is very much capable of fast and easy cuts, and with a little bit of practice can be somewhat precise. xTool states that the Metal Fab can cut stainless and aluminium of up to 4mm, 3mm brass and carbon steel up to 1mm with just compressed air, and any carbon steel over 1mm up to 10mm needs oxygen. But because my biggest issue with handheld cutting was that I couldn't move the laser fast enough to not burn everything underneath, I had the suspicion it might be able to handle more than 1mm carbon steel with just compressed air. So this is 3mm mild steel, easily cut. So I tried 3.6mm high carbon knife steel, which also cut with ease. This is great news for me specifically because I can work with my standard material with just compressed air. And then just for the fun of it, I tried 10mm mild steel as well, and this is definitely the point where you need oxygen for. So in conclusion, handheld cutting could be fantastic if it wasn't for the safety loop, just like with rust removal. If you can just afford to buy the Metal Fab itself, handheld cutting probably is still faster than an angle grinder, but where the laser cutting really shines is in combination with the CNC platform. I started off by making this test project you get when setting up the CNC platform in xTool Studio, which is this cool balancing bird, and now that I was somewhat familiar with the interface, I wanted to do some real-world application. 2 weeks ago I asked which design you would prefer to make a keychain hanger, and with a resounding victory, my personal favorite one. Setting everything up is pretty easy. I could import a PNG of my design and have the software automatically trace out the outline of the image to produce a vector image for the cutting path. With a catalog of different different material presets. I could also just type in 2mm stainless and everything was ready to go. Truth be told, the first and second cut didn't work. I always got a collision warning, but the troubleshooting attached to the error quickly told me how to resolve the issue though. I had to increase the material thickness from 2mm to 2.5 to ensure that it cuts through. There it is, first try with the updated values. So let's do some more of those. Now this was the one with the laser head collision. You can see that it's screwed up. So this one didn't cut through because the piece that was stuck here moved the laser out of the way. This is a reject. Now, I don't think this is necessarily the machine's fault because they just happen to fall in a peculiar way and it's a pretty intricate shape. If you got important parts where failure is a big problem financially, you would probably want to design it in a way that there are little small bridges between the parts. So there's just like 0.1mm bridge holding the parts in place and then you punch them out afterwards. But in my case, I'm okay with having one reject because that means I don't have to do anything with the other ones. I think that's more of a product design issue than anything else. So after looking at the first test cuts, I decided to make the whole hanger a little bit bigger. So I just scaled it up in the software, and I also made this little part at the top a little bit bigger as well. So in total, I've cut 35 of these hangers so far, and I had 2 collision failures, which I think is a pretty okay quote. But as I said, the machine can't do anything about gravity. These cuts were with the standard 2mm nozzle, and they also send you a safe gas nozzle. With the 2mm nozzle, you are supposed to have 1200 kilopascal of air pressure, and with the safe gas nozzle you can reduce that to almost half. In this case I could just use 600 kilopascal, and supposedly it gives you a burr-free finish. In my testing it didn't result in much of a burr-free finish. In general the burrs definitely were noticeably smaller, but the way it achieves this low pressure good finish is there's a little ceramic tube that drops down onto the material, basically creating a seal, and then you constantly got contact with the metal. But in my case, with very many pieces falling out, you can imagine that increases the likelihood of creating a collision. And you can see on this piece, even a small collision slightly deviates the path and the cut is messed up. So because I have to go to the belt grinder anyways, in my case, the standard nozzle without a burr-free cut is better than the safe gas nozzle. Now, if you were to use something like oxygen or argon, where it's expensive, you obviously might consider that, but with compressed air, it's not really an issue. I also tried cutting out the same design out of 2mm brass, and at first I thought it didn't work at all because they didn't drop down like the stainless steel ones would. And then I saw it was more of a suffering of success kind of story because the cuts are so thin that the burr on the backside fuses back together, holding everything in place, and I need to apply a little bit of pressure to plop out the individual pieces, and then it looks pretty great. But a little bit of extra labor. Not to sound all high on copium, but honestly I don't really care that much about the burr-free finish anyways, because I have to take it to the belt grinder anyways, and I think most pieces you cut need some kind of post-processing. The burr isn't as noticeable as it would be with plasma cutting, so I think it's alright. And then the last thing to try out was engraving. In this case, they call it combined processing, which means the first task will be laser engraving a design on there. And the second task, you can cut around it or do whatever you want, maybe like a little plate or something. On a different note, xTool wanted me to showcase their AI features because nowadays everyone has to show off AI features everywhere. In case of the outline tracing of my keychain design, I really like AI features because you can tell the vector image created was fantastic. Just to try engraving, I kind of half-assed threw this thumbnail of my Polex video into the photo to line art they have right in the xTool studio. I didn't expect much, but honestly I was kind of blown away. by what it spit out. Turned out pretty great. I had to make a little sign, so I made this watch your head sign to try out the combined processing, and honestly I love it. It's great. I have to try out engraving a little bit more. On this design, I don't know if it's because it was AI generated and the resolution wasn't high enough, but you can definitely tell up close it's not as crystal clear as you would want it to be. Sorry, I have to say I didn't try another image, so I can't really with 100% certainty say if it was because the machine is not primarily focused in engraving, so it's a little bit pixelated, or if it's just the image that has a too low resolution. Okay, so the CNC platform, by far my favorite feature of this machine. The cuts are super fast, very precise. It's easy to set up, it's easy to change. You can quickly take everything out to take it back to a welder. The software is easy to set up. It explains exactly what you have to do, what kind of different focal lengths you have to put in there for different materials combined with their material preset. It's pretty much foolproof, and even if there are some errors, they are very minor and easy to fix. Now, probably the biggest problem, let's call it that, is the price point. The laser welder itself is already pretty expensive. Both of these together cost around 20,000 euros, which is a huge investment, more than I could ever invest right now. But honestly, after doing the chain hangers, let's just do the math right now. This piece of stainless steel cost me around 25 to 30 euros. There fit around 60 of these hangers on there. So for ease of calculation, let's go with 30 euros, 60 pieces, that's 50 cents per unit. Then also I need a little bit of abrasive, some consumables for my belt grinder, got the rotary tumbler and everything, and then also electricity. But let's be generous and say that's 3 euros, probably a lot less. 3 euros of material cost per hanger. And I'm going to sell them for 15 euros because I think that's a very reasonable price. That's a 12 euro profit per unit. Let's do the math on that. I stopped my time for making 10 of these. Anyone who ever made some batch production knows that making 20 pieces of something doesn't take twice as long as making 10 pieces of something. It's far less, because not having to move between machines eliminates a lot of time. But let's talk about 10 pieces. Turning everything on, putting it into the software, loading the material, setting everything up, cutting it, taking it over to the belt grinder to a first 120 grit finish, putting it into the rotary tumbler, taking it out, going back to the belt grinder, doing 2 separate belts, and then polishing afterwards. Took me, for 10 pieces, altogether 50 minutes. Which means 5 minutes per piece, which is no work at all. Just because the back end also needs some time, let's also add 5 minutes for setting everything up for shipping, putting it into the box, and then also printing out the receipts and everything, which means 12 euros of profit in 10 minutes. I can make 6 per hour, which means I got 72 euros of profit per hour, which means with 72 euros per hour, I would have to work 278 hours to accumulate 20,000 euros. Divided by 40-hour work week, 6.95. So 7 weeks in far less than 2 months, you got this machine paid off with this project. So I was very surprised by this, that yeah, xTool is right. This thing pays itself, and it pays itself quickly if you get to sell everything. Honestly, in my case, not really feasible for me. My business isn't focused around selling stuff. I just do it on the side because I like making it, and I also think it's cool to produce your own merchandise. In the past, it wasn't very financially responsible to do that. Now it actually is. You can see 72 euros. My other projects, just to be somewhat in a profitable range, I calculated with 25 euros per hour. Not very good for having all of this upkeep. Now 72 euros, almost triple that. Yeah, even for me, this machine would quickly pay itself off. You definitely get your money worth. Okay, so before I get to my final conclusion, just a quick note about safety. You can tell they really made sure to have this thing as safe as possible. It's still very dangerous. In fact, it's so dangerous that in the EU at least, you can't own this as a private person. You have to have a business that is registered. Otherwise, you can't buy this machine because it's a class 4 laser. In the US, I think it's different. but at least in the EU, you can't buy this without having a business. Even though, I was a little bit unhappy with some of the safety features for laser cleaning and cutting, I'm a little bit stingy about my eyesight. I want to keep these peepers as long as possible. I reached out to xTool just to clarify, you can use these for welding. They send you this pair that's rated for the exact laser wavelength of the laser module. While welding, it was very bright. It was very hard to look at what I was welding, but they stated that this is safe enough for typical welding, but they also recommend you get their xTool welding helmet. This thing is 130 euros. Honestly, if you're paying 20,000 for this machine, get these. I took every precaution because even reflected light can burn your skin. Even with my precautions, there are still some areas where you might get UV or laser burn while using this machine. If you are going to buy the machine, just get this. I don't know why they don't send you one in the first place, but get this. They recommend it. I definitely recommend it. You only have two eyes, so be mindful about them. So, in conclusion, the Metal Fab and CNC cutter. Definitely, absolutely love this machine. If you use the CNC platform and the welder in unison. Just the test project, the little balancing bird, just shows how great these two machines work together. And it just, opened my eyes to the world of possibilities with this machine setup. The cutting feature is absolutely 10 out of 10. This thing has vibration dampening. The cuts are buttery smooth. The smart cameras are doing a perfect job getting the last little bit out of your material. So now, after having worked with this machine for the past 2 weeks, I definitely have to say, I don't want to think about a time without this machine. This will be a whole new level of productivity in my workshop. My projects will be a lot more feasible. I can finally do something more intricate that I always had to shy away from because doing everything with an angle grinder and a file just takes too long, isn't financially responsible. If you are just going to buy the Metal Fab welding platform, I don't know, take some extra cash in hand and get both of these machines, I think you'd be missing out. As my first impression right now, I wholeheartedly recommend this machine, but I don't want to be talking out of my ass. I just used this for 2 weeks, which I think was a very great decision by xTool that we're making a small series and I get to use it on actual projects, and then you can see how much faster I can get these done. I hope I could give you some insights into xTool's Metal Fab. I definitely think I can paint a more clearer picture once I've got the next 3 projects done. And if my opinion changes significantly, maybe I'll do another review video. But the next project, Project Gateway, will be something that I've been cooking up for the past year. And I hope it'll be an introduction for most people to how great it is to own a high carbon cooking knife. I think the Metal Fab CNC platform will be a perfect fit for that project, depending where you are, in Germany at least, and from neighboring countries I've heard. Sometimes CNC and water jet cutting companies don't like to cut knife blanks or anything adjacent to knives because they don't want to deal with quote unquote weapons. It'll be interesting to see how I can use the laser cutting CNC function for high carbon steel. Let me know what you think about the Metal Fab. Check out xTool. If you do want to buy it, you can use my affiliate link down below. That way I get a little kickback without you having to pay anything more. And I hope you guys are doing well, and I catch you in the next one. Bye.